Hi everyone, welcome to this workshop. Today we practice on factoring by formula. So first of all, let's talk about the factor, the difference of two square. So the mathematicians say that if you have a square minus b square, we will have a plus b times a minus b. Now let prove is that true. Let prove for ourselves is that right. Say that on my right hand side you have a plus b times a minus b. Let FOIL this one and then see will we have a squared minus b squared. So we're gonna do is distribute a. We will have a squared. A times negative b is negative ab, and we also distribute b into the second parenthesis, so we will have b times a will give me positive ab. B times negative b is negative b squared. So as you see, the middle term has the opposite side. Negative ab and positive ab will be canceled out, leave us with a squared minus b squared. A squared minus b squared. So as we see that when you have the binomial, two binomial multiply each other with the opposite side, we will have a squared minus b squared. So we need to remember or learn by heart the formula. A squared minus b squared equal to a plus b times a minus b. So the formula really important in this section. So my suggestion is spend 5 minutes or 10 minutes to learn the formula, and then we will talk how to apply this one in factoring. So the way I remember this formula is if I have a squared minus b squared minus b squared. So the way I remember it, whatever I have, bring it down, drop the power. So I will have a minus b. Okay, then my second term, you have a squared, you take 1 already, you still have 1a. B squared, you take 1 already, you have 1b. The second group have to have the opposite side. So that's the way I remember the formula. It's still equivalent with the formula they give you, because the product property allow me to switch term around what's called commutative of the products form. All right, so just spend 5 minutes, 10 minutes, or write 10 times or 20 times until you remember the formula. Then we will talk about how to apply this one in factoring. Now let's go over 3 examples to see how can we apply the difference of square to factor the following problem. So let's start with example 1. You have x squared minus 9. Compare with the formula, you see that a squared minus b squared. To be able to apply the difference of square, you need to have square minus square, difference of square. So square minus square, which means that I need to rewrite this 9 at the number raised to the second power. So with number raised to the second power give me 9, that is 3 squared. Okay, so my first step to deal with factoring by formula is rewrite my problem at x squared minus a number square. So as you see, again, we have square minus square. Then I can apply the formula. So you can use that x plus 3y times x minus 3y, or you can apply the tip I just told you before, which means whatever we have, bring it down, drop the power. So x minus 3. And x squared, you take 1 already, we have 1 more x. And 3 squared, you take 1 already, we have 1 more 3. And the second group will have the opposite side with the first one. That is the way I learned the formula. Then if you want to check, here we go, we will check the answer. So let's say checking. I can do is FOIL them back and see will I have x squared minus 9. So x times x give me x squared, x times 3 is 3x. Then we also distribute the negative 3 will give me, so this one is 3x. So negative 3 times x will be negative 3x. Negative 3 times positive 3 is negative 9. And you see that the middle term, positive 3x and negative 3x will cancel out, give me with x squared minus 9, and that match with the original problem. So x minus 3 times x plus 3 is the answer of this problem. To make sure we see the formula, the final answer, so I will rewrite them one more time. X minus 3 times x plus 3 is the final answer of that problem. Now example 2. So as we learned from the previous example, you need to rewrite those numbers in terms of square. Something square give you 25 and something square with number square give you 49. So as we see that 25 is 5 square give you 25 and 49 is 7 square give you 49. Then we bring out the rest, so we have x squared minus 7. Okay. This one almost looked perfect, but it's so many terms squared that's confused me. So I'm gonna do is rewrite the first one, 5 squared times x squared can also be rewrite as 5x and the whole thing squared minus 7 squared. Okay, writing this way, we can see that 5x is my A and 7 is my B compared with the formula. So 5x is A and 7 is B, so that we can apply the formula. And we also see that we have square minus square. So you can either apply the formula or you're gonna do like me. Whatever we have, bring it down, drop the power. So we have 5x minus 7. Okay. The second group will be the opposite side. So 5x squared, take 1 already, you still have 1 more 5x. 7 squared, take 1 already, you still have 1 more 7. And we see that the sign will be opposite. Opposite side. Opposite side. Okay. Now let's go over example 3. So from two previous one, we see that we need to rewrite 8 and 32 as the number square. But 8 cannot be, no number raised to the second power give you 8. Also, no number raised to the second power give you 32. So, which means that there's something in common here. We need to factor out the greatest common factor. As always, when you do the factoring, keep in mind, whatever you do by formula or by any other method, we have to think about the greatest common factor first. So we have 8 and 32. What is the greatest common factor? 8 goes to 32 is 4 times, so which means 8 is the greatest common factor. So my first step is factor out the 8. Factor out 8, so which give me left inside with x squared minus 4. Now you see we have x squared minus 4, which means 4 can write in terms of square. So as we see that 2 squared give you 4, so my next step is rewrite the problem as bring down the 8. So x squared minus 4, I just say that 4 is 2 squared. Okay, right in this form, you will see that we have square minus square. Then we can apply the difference of square. So we will have 8 times with whatever we have, bring it down, drop the power, x minus 2. And the second group will be the opposite side, will be x plus 2. And that's how you apply the difference of square formula in factoring. So the next step, let's go over some cell check, see how we practice and did we understand how to use it. So check, I have 4 problems for you to practice on. So make sure you understand how to factor a binomial by formula, the difference of square. So I still keep the formula up there for you. Um, as long as you understand the concept and you understand the example, you will be fine on those 4 problems. You will be surprised later on, but it's a good surprise. We learned something new. All right, so try on it. Have fun. Good luck, everyone. You have 5 seconds to pause the video before the answer show on the screen. All right. Good luck. All right. I believe we have our answer already. So let's work this through together and then see do you have the same answer like my answer. So problem 1, you have x squared minus 81. So we know that we need to rewrite the problem. 81 is 9 squared. So first of all, rewrite the problem. We have x squared minus 9 squared. Then we have whatever we have, bring it down, drop the power. So x minus 9. The second group will be the opposite side, x plus 9. Okay, that's the answer for 1. Now number 2, you have 9m squared minus 64m to the 4. So as we say that we need the second power, so then 9 is 3 squared. Okay, 64 is 8 squared. N to the 4, I need n squared. So this one can be also write as n squared square, which give me n to the 4. Okay, then I bring out the rest. So we have m squared minus that. So that still not look really nice. I need to rewrite on both sides one more time. Instead of 3 squared times m squared, I can rewrite it as 3m and square outside minus we have a squared times n squared squared. So I put the square stay outside. So you will have a n squared inside parenthesis, and the square in the circle will stay outside. So we have square minus square, which tell me I can apply the formula. So whatever we have, bring it down, drop the power. So 3m minus 2n squared. Even I write n squared, we drop the power outside, not inside. We drop this power outside. And we also have the second group with the opposite side. So 3n plus an squared. And my bad on the long way writing down, this one should be m, I write m. So this should be m. So that is the answer for problem 2. Now in problem 3, we see that there's no number. First of all, the problem too complicated. There's so many variables, and there's no number. Square give you 2. Also, square give you 8. Would mean we have something in common. Let's find out what is the greatest common factor. So as we see that 2 going to 8, so I have 2 will be the greatest common factor. A squared here, we don't have a squared on the other side, so a squared is not a common factor. X to the third and x, so we have x to the first power is the lowest term. That would be another greatest common factor. And y on both sides, so it would mean y also is the greatest common factor. So I factor out 2xy, so leave me inside with a squared x squared minus 2xy times what number give you ab squared xy, so it would be 4b squared. If you don't know what I'm doing right here, you should go back to the previous video when we're talking about factor out the greatest common factor to make sure you understand the concept. Now on this step, we need to rewrite them one more time in the right form of the difference of square. So as you see that we have a squared, x squared, so we can rewrite them um, as ax squared outside, ax squared outside, my bad, ax, and the square stay outside. And I'm gonna do the second thing is replace this parenthesis at the big one, or I will rewrite at the bracket. It's also the big parenthesis. So 4 right here will be known as 2 squared. So this will be rewrite as minus 2b with the square stay outside of the small parenthesis. And I need the bracket to close them up. And bring down to xy. Okay, so the last step is apply the difference of square for the binomial inside. So bring down to xy. Whatever I have, bring it down, drop the square. So let me emphasize this is square minus square. That's the one I want. So whatever I have inside, bring it down, drop the power. So we have ax minus 2b. The second group will be the opposite sign, will be ax plus 2b. There we go. That's the complete factor of problem 3. Okay, the last problem, example 4. Example 4 have the same idea like example 3, which means we have to factor out the greatest common factor, but they also have something extra. Let's go over this one and see. So we have 2 go to 32, 2 will be the greatest common factor, y on both sides, so y also another greatest common factor. So factor it out, 2y stay outside, so leave me inside parentheses is x4 minus 16. Okay, so x4 minus 16, I need to write them in terms of the difference of square, in form of the difference of square. So we will have the following, 2y, this one x4, I need x squared to stay outside, so I need to replace this parenthesis at the big one because I need the small one for my x squared with the square outside. So x squared square give me x to the 4, and 16 will be rewrite as 4 square. Close the bracket. So then we see that we have square minus square, so it would tell me I can apply the difference of square. So we will have 2y times with x squared minus 4 times x squared plus 4. X squared minus 4 is also another difference of square because you have 4 is 2 squared. Okay, then this problem will be rewrite as 2y x squared minus 2 squared will be x minus 2 times x plus 2. Okay, with the second group we have x squared plus 4, which means x squared plus 2 squared. But the problem is we have the positive is not negative. We don't have the sum of square, so this one basically stay exactly as they are. So it will be x squared plus 4. Again, because it's plus, we don't have the sum of square, so that's why x squared plus 4 still stay exactly the same. Okay, so we just learned a new thing in this problem, which is if you can keep going factoring them down, you have to keep going until you cannot do anything further. And the second thing is we don't have the sum of square, so this one cannot be break down at 2 parentheses like x squared minus 4. So you should write a note somewhere, don't have the difference of square. Let me write here, don't have a difference of square. I mean the sum of square. Sum of square. Square. Formula. Okay, this one really important. We always most of the time we get wrong here. We think that we can do further, but actually we don't. Okay, all right. Let's go to the next section. Now let's talk about the sum of cube and the difference of cube. Mathematicians say that if you have a to the third, let's say the sum of cube first, plus b to the third, you can also factor them as a plus b times a squared minus ab plus b squared. So let's see, is that true? Okay, so on the right hand side we have a plus b. We have a plus b times a squared minus ab plus b squared. So to prove this one, we're going to do is distribute a into the parenthesis. So into all three terms, we will have the following. You will have a times a will be a times a squared, give me a cubed. A times negative ab will be negative a squared b. A times b squared will be positive ab squared. We do the same, distribute b into the second parenthesis. So we will have b times a squared will be positive a squared b. B times negative ab will be negative ab squared. B times positive b squared will be positive b to the third power. So as you see in the middle, we have negative a squared b and positive a squared b. They will be cancelled. And also we have positive ab squared and negative ab squared, so they will be cancelled too. So the left us with a to the third plus b to the third. So we see that a to the third plus b to the third is also be written as a plus b times a squared minus ab plus b squared. And that is the sum of cube. We also have the difference of cube, which is a to the third power minus b to the third power, will be written as a minus b times a squared plus ab plus b squared. Okay, so both formula right here are really important. You may want to spend about 5 for each formula, 5 or 10 minutes for each formula to remember them. You have to learn it by heart. Okay, the way I remember the formula is like this. You have a to the third plus b to the third. So the idea is the same. Whatever you have, bring it down, drop the power. So we will have a plus b. Okay. The second group, we have a to the third, you take 1 already, so you have a squared. B to the third, you take 1 already, you have positive b squared at the end. The middle term will be, first of all, will be an opposite side with the first one, and then a, b go together, so a times b. That's how I remember the formula. So first group stay exactly the same. This one is opposites, like we learned last time. The second group will have the opposite side, and this one is always positive. Okay, let's see, the formula I just told you will apply for the difference of cube. So we have let's use just a different color here. So we have a to the third power minus b to the third power. Whatever I have, bring it down, drop the power, so it would be a minus b. Okay. A third, take 1 already, so we have a squared. B third, take 1 already, so we have b squared. As we see, the last one is always positive, so this one would be plus. And the middle one is opposites with the first one, the opposite side with the first binomial. So this one plus, this one minus, so it should be plus right here. And AB go together, so plus AB. and we see this one match with that. So you can do either use the flashcard to learn the formula or rewrite them 10 times, 20 times until you remember them, or you can apply the trick like me, understand how to build it up. So spend some time, remember the formula is the most important. Then we will go over some examples to see how can we apply the formula in factoring factoring by the difference of cube or the sum of cube. So let's look at 3 examples we have right here. I also keep the formula on the top for you, so just in case you don't remember the formula yet, but try your best. When you solve the problem, don't look at the formula. Try to learn the formula before you actually solve it. So here we go. Example 1, x to the third plus 8. So based on the formula, you see that a to the third plus or minus b to the third, which depend if it's plus, so you follow the yellow sign. If it's minus, then you follow the red sign for the rest of the formula. So either one, the sum of cube or the difference of cube, we see that we have to have the third power, either plus or minus the third power of the second term, which tell me that I need to rewrite this 8 as a number raised to the third power. So which number raised to the third power give me 8? So we know that 2 raised to the third power give me 8. So I need to rewrite my problem as x to the third plus 2 to the third power. Then we apply the formula as the tip I told you before. Whatever we have, drop it down, bring it down, drop the power. So we will have x plus 2 without the power. Now the second group, so this one is the sum of cube. The sum of cube. Then it's a little bit different with the difference of square. So x to the third, you take 1 already. We have x squared. 2 to the third, you take 1 already. So you have 2 squared at the end. Okay, the sign right here will be opposite sign with the first one, so it would be minus, and first 2 terms go together, so 2 times x is 2x. This one is not the final answer yet, because you have to tell me what the 2 square is. So I need to rewrite the whole thing one more time as x plus 2 times with x squared minus 2x plus 4. Now this is my final answer here. So with the same idea, we're going to solve example 2. 8b to the third minus 27c to the third power. So 8 we already see is 2 to the third power give you 8. How about 27? Which number raised to the third power give you 27? So what is 3? 3 to the third power give you 7. Okay, then I bring down the rest. So b to the third minus 3 to the third, c to the third. Then I need to rewrite them one more time with the power stay outside of the parenthesis. So we have 2b, the whole thing raised to the third power, minus 3c, the whole thing raised to another third power, like this. Okay, then I can apply the way to write formula like I told you before. So we will have whatever you have, bring it down, drop the power. So 2b minus 3c. Okay, so the next one, in this case I will use parenthesis, the bracket, because you will have the small parenthesis inside. 2b to the third power, we take 1 of 2b already, so which means you have 2 more, so it means 2b squared. The parenthesis right here really important. That will remind you that the power, the square stay outside, will be applied for both for 2 and also for b. Okay. Now 3c raised to the third power, we take 1 already, so we have 2 more, so we have 3c raised to the second power, close the bracket. So we have the last one always positive, and the middle one will be opposites with the first one. Since the first one is negative, so this one will be plus, and two first term go together, which means 2b times 3c. Okay, now the final answer will be rewrite without any parenthesis in here or multiplication here. You have to work it through. So we will have 2b minus 3c time with 2b squared will give me 4b squared. 2b times 3c will give me 6bc, and plus 3 squared will give me 9, and c squared, just bring it down. And that is the final answer for example 2. That is the difference of cube. Now on this one should be example 3. On example 3, we have negative 2t to the fifth plus 128t squared. So the last example, we learned that if the problem starts with the negative, you have to factor the negative out. And beside that, we also need to looking for the greatest common factor. That's the first step of all kind of factoring. So I'm gonna factor out the negative 2, not just only the negative 2. We have negative need to be factored out, and also 2. And if you look at here, we have t to the fifth and t squared, which means t squared in common, since it's the lowest power we of t variable. So we factor out negative 2t squared, which left me inside with negative 2t to the fifth. You factor out negative 2t squared, we have t to the third power. Negative 128, you factor out negative 2 will give you negative of 64, and t squared already stay outside, so that's it for the term inside parenthesis. Now my next step is rewrite this problem with number raised to the third power give me 64. So with this 4 to the third power give me 64. Then I bring down the rest. So negative 2t squared time with t to the third power minus 4 to the third power. Since we have third power minus third power, that's the difference of cube. So we apply the formula as I showed you before. Whatever we have, bring it down, drop the power. So t minus 4 without a power. T cubed, take 1 already, so we have t squared. 4 cubed, take 1 already, so we have 4 squared at the end. The middle one will be the opposite side, which is plus, since this one negative. And first two terms go together, so we have 4t. So we have negative 2t squared time with t minus 4 time with t squared plus 4t plus 16. And that is my final answer for example 3. So check, I have 4 problems for you to practice on. So make sure you understand the concept. If you still confused, go back to the example. The most important is remember the formula before you solve those problems. You will see some new idea in those examples, but it's still fine as long as you understand the concept, you know how to do it. So good luck everyone. You have 5 seconds to pause the video. After that we will discuss each problem, and then I will express some more new idea. Alright, enjoy. You have 5 seconds. Okay, I believe you already have your answer, so let's go over each of them and see do we get correct answer. So we have p to the problem 1, we have p to the third plus 64. So first of all, I need to rewrite p to the 64 as a number raised to the third power. So 4 raised to the third power give me 64. then I also need to rewrite the whole thing, p to the third plus 4 to the third. So whatever we have, bring it down, drop the powers. So p plus 4, p third, take 1 already, so we have p squared. 4 third, take 1 already, so we have 4 squared. The middle term has the opposite side, and two first term go together. So the final answer would be p plus 4 times p squared minus 4p plus 16. And that's the final answer for problem 1. Problem 2, so I need to rewrite 27 and 8 as the number raised to the third power. So we have 27 is 3 to the third power, and 8 is 2 to the third power. Then we bring down the rest, m to the third minus 2 to the third. So next up is write 3 to the third and m to the third as 3m raised to the third power minus 2 to the third power. Then we apply the formula. Whatever we have, bring it down, drop the cube. So 3m minus 2. 3m to the third, you take 1 already, so you still have 2 more. So I use the bracket here. 3m to the second power. 2 to the third, take 1 already. We still have 2 to the second. And the middle term has the opposite side, and first two terms go together, so 3m times 2. So the final answer of this problem is 3m minus 2 times with 3m squared would be 9m squared plus 6m plus 4. Okay, now example 3, we have negative 3p to the 4 plus 81p. Since we have p to the 4 and p right here, which means we need to find the greatest common factor. So first of all, p will be uncommon. And 3 also go to 81, so 3 also in the greatest common factor. And since the problem starts with the negative, we also have to factor out the negative. So I will do is factor out the negative 3p, leave me inside with negative 3 out, and p to the 4 take 1p, so we have p cubed. And positive 81, you pull out negative 3, so we will have negative 27 left, and this p also come out, so just negative 27 is the last term in the parenthesis. So my next step is rewrite 27 as 3 to the third power. Give me 27. We bring down the rest. Negative 3p times with p to the third minus 3 to the third power. Then we apply the formula. So we have p minus 3 times with p squared plus 3p plus 3 to the second power. So it would be second power, so it would be 9. And that's the final answer for problem 3. Now, on problem 4, we have x to the 6 minus 64. So since this one is the 6, you can break it down either. You can break it down as x to the third power square, or x to the square raised to the third power. So if you write it in this form with the square outside, we have to apply the difference of square. If you put the cube outside, we're going to apply the difference of cube. But the best way when you deal with the problem can be write either the difference of square or the difference of cube. We definitely have to write in the difference of square first. Let's solve it by the difference of square, and then let's see, I will erase somewhere here to write the difference of cube, and then see which one is the completely factoring of this problem. So as we just say, write in the difference of square. So I will have x to the 6 will be rewrite as x cubed raised to the second power, and minus 64 will be rewrite as a to the second power, give me 64. So with this one, to apply the difference of square, with this one we have square minus square. We're gonna apply the difference of square. So we have x to the third minus 8 times x to the third plus 8. That's the difference of square formula. Then you see this one break down at the difference of cube and the sum of cube formula. So which means this can be expanded further. So first group will give me x minus 2 times x squared plus 2x plus 4 for this one. As we know that is 8 is 2 to the third power. And the second group will be breakdown as this one will give me x plus 2 times x squared minus 2x plus 4. So my final answer is x plus 2 times x minus 2 times with x squared plus 2x plus 4 times with x squared minus 2x plus 4. And that is the final answer for problem 4. So as I told you that we shouldn't use the difference of cube from the beginning. Let's go by the direction of the solve this by the difference of cube and then see where it will lead me to. x6 minus 64. So we say that we if I solve it by the difference of cube first, so we have x squared times with x squared to the third power minus 64 is 4 to the third power. So we will have whatever we have, bring it down, drop the power. So x squared minus 4. And on the other side, we will have x squared to the third. You take 1 already. So we have x squared squared left on this side. And it's plus 4x squared plus 4 squared give me 16. So on this side we have another difference of square here, which will give me x plus 2 times x minus 2 time with this one give me x4 plus 4x squared plus 16. So as you see, this one is not completely factoring compared with we saw by the difference of square first. You see it's breaks much smaller at 4 different groups, and each of this is the prime factoring. This one you just have 3 groups, and this one x to the 4 power and x squared, and 16 even 4 squared. So it's not really completely factoring compared with this answer. So be careful, if you go this direction, you probably don't have the full credit by factoring this way. Okay, so remember this the trick, the tip here to give you the full credit. Alright, to close today's section, we have some extra practice for you to work on. So before you practice on this one, make sure you go back to the example and self-check before. Make sure you understand the concept and which one we have the formula, which one we don't have the formula. That's really important. Don't create your formula, okay? And the other idea I want to tell you is 1 is the special number, like I'm talking about problem 8. 1 is the special number. You can do 1 to the third power, also 1. 1 to the second power is also 1. So this one can be rewrite either the cube, the second power, whatever power you put it still give you 1. So and what else do I want to okay, and make sure whatever you do, remember the greatest common factor. If it doesn't work out really well, so use the greatest common factor first. Alright, I believe I give you all the idea and the hint to solve the problem. So go ahead, have fun on those problems, enjoy, good luck. I hope we all get correct answer. So answer will be show up on the screen in the next 5 seconds. So have fun everyone. Alright, answer up. So go through and check your answer. I hope that we all get correct answer. So just only one small idea I still want to express through here. So right here in problem 2, you have 4a squared plus 9y squared. So we don't have the sum of square. So this one is prime. You cannot break the smaller, but the whole problem is not prime because you already factored 2 out. So problem has the answer, which is this one. Okay, it's not prime. Just this one, the one inside prime, because you cannot break it smaller because it's not a difference of square. And the second interesting problem is problem 9. As you see that we have x in common, which means you can factor x outside, and also y in common, which means you can factor y outside of the second parenthesis. Then you will see that a plus b and a plus b on both sides, so you can group that one, factor that one out. Then you will see the rest answer right here. And the last one, number 7, you have 64 minus z to the third. So you can either read all the thus with z in front, negative z cubed plus 64, and then factor negative outside, z to the third minus 64, and solve through. You will have a different answer with the one I given, but it's still correct. So I hope we all have fun on factoring with the formula. Okay. So as always, thank you for watching, and I'm looking forward to see you in the next video, which is about factoring trinomial. It's really an interesting concept I want to express through. I want to show you. So see you in the next video.